Here's how to wire a low-water cut-off device to a boiler and gas burner system. Firstly, disconnect the existing wires from the boiler control box's N and B2 terminals. Secondly, connect these wires that were disconnected to the low-water cut-off control box's terminals labeled 2 and P2. Thirdly, connect the low-water cut-off control box's terminal 2 to the burner circuit's common. Neither the TW nor the TR terminal is considered the common in this setup. This configuration ensures that the low-water cut-off has control over the gas burner operation. When the water level in the boiler drops below a safe threshold, the low-water cut-off interrupts the connection between terminal 2 and the burner circuit common, effectively shutting off the gas burner to prevent damage or hazardous conditions. The rationale behind this wiring setup is to provide a safety mechanism that prevents the boiler from operating when the water level is dangerously low. Without adequate water, the boiler's heating elements for heat exchanger can overheat and potentially cause damage, such as cracking or melting. The low-water cut-off acts as a safeguard, ensuring that the burner only operates when there's sufficient water in the boiler. It is extremely important to always refer to the manufacturer's instructions for the specific low-water cut-off model and gas burner being used. Installation and wiring details can vary depending on the equipment, and following the manufacturer's guidelines ensures proper and safe operation. Before making any connections, verify that the voltage compatibility between the low-water cutoff and the gas burner is correct. Most systems use a 24 volts control circuit, but it's essential to confirm this to prevent damage to the components. Use proper electrical connections, such as wire nuts or crimp-on connectors, to ensure secure and reliable connections. Make sure all wires are securely fastened to the terminals to prevent loose connections, which can cause malfunctions or safety hazards. It's also recommended to use appropriately sized wiring for the connections. Refer to the National Electrical Code, specifically NEC Table 310.15b16, to determine the correct wire gauge based on the amperage of the circuit and the wire's insulation type. Using the correct wire size helps prevent overheating and potential fire hazards. Remember that working with electrical systems can be dangerous if not done properly. If you are not comfortable or experienced with electrical wiring, it's best to consult a qualified electrician or HVAC technician. The NEC, or National Electrical Code, provides comprehensive standards for safe electrical installations. Here are some relevant articles of the 2017 NEC that might apply to this type of installation. NEC Article 430 covers motors, motor circuits, and controllers. While a boiler system might not have a traditional motor, the principles of motor circuit protection can be relevant to protecting the various components in the boiler system. NEC Article 440 covers air conditioning and refrigerating equipment. Although this article is specifically for air conditioning and refrigeration, it provides guidance on disconnecting means, branch circuit protection, and control circuit wiring, which can be applicable to boiler control systems. NEC Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. Boiler control circuits often fall under Class 2 or Class 3 circuits due to their low voltage and limited power. Article 725 provides requirements for wiring methods, overcurrent protection, and separation from other circuits. NEC Article 300.11 addresses securing and supporting wiring. All wiring must be properly secured and supported to prevent strain on connections and to protect the wiring from physical damage. This is especially important in mechanical rooms where there may be vibration or movement. NEC Article 310.15 provides guidelines for ampacity of conductors. It's important to select the correct wire size based on the ampacity of the circuit to prevent overheating and potential fire hazards. Use NEC Table 310.15b16 to determine the allowable ampacities of insulated conductors. NEC Article 250 covers grounding and bonding. Proper grounding and bonding are essential for electrical safety. Ensure that all metal parts of the boiler system are properly grounded to prevent electric shock hazards. NEC Article 422 covers appliances. Boilers are considered appliances, and this article provides requirements for disconnecting means, overcurrent protection, and wiring methods for appliances. NEC Article 110.3b states that listed or labeled equipment must be installed and used in accordance with any instructions included in the listing or labeling. Always follow the manufacturer's instructions when installing and wiring a boiler system. When wiring a low water cutoff, the primary goal is to ensure that the boiler shuts down safely if the water level drops too low. This prevents damage to the boiler and potential hazards. The low water cutoff typically has a float or probe that senses the water level. If the water level drops below the set point, the switch in the low water cutoff opens, interrupting the circuit to the burner. To properly wire the low water cutoff, you need to identify the control circuit for the burner. This is usually a 24 volts alternating current circuit. The low water cutoff is wired in series with this control circuit. This means that the power for the burner control must pass through the low water cut-off switch. When the water level is normal, the switch is closed, allowing power to flow to the burner control. If the water level drops, the switch opens, cutting off power to the burner control and shutting down the burner. Here are the general steps for wiring a low water cutoff. Firstly, turn off the power to the boiler. Before working on any electrical components, always turn off the power at the circuit breaker to prevent electric shock. Secondly, locate the burner control circuit. Identify the wires that supply power to the burner control. This is typically a 24 volt alternating current circuit. Thirdly, disconnect one of the wires. Disconnect one of the wires that supply power to the burner control. This wire will be routed through the low water cutoff switch. Fourthly, connect the wire to the low water cutoff. Connect the disconnected wire to one of the terminals on the low water cutoff switch. Fifthly, connect the other terminal. Connect the other terminal on the low water cutoff switch to the burner control. This completes the circuit. Sixthly, test the low water cutoff. After wiring the low water cutoff, test it to ensure that it is working properly. Lower the water level in the boiler to simulate a low water condition. The burner should shut down. If the burner does not shut down, check your wiring and the operation of the low water cutoff switch. When connecting the low water cutoff, make sure to use the correct wiring size and type for the application. Use appropriately sized wire connectors and ensure that all connections are tight and secure. Label the wiring so that it can be easily identified in the future. This will help with troubleshooting and maintenance. Consider the specific requirements of the boiler and the low water cutoff. Some boilers may have specific wiring requirements or recommendations for the low water cutoff. Refer to the manufacturer's instructions for guidance. If you are not comfortable or experienced with electrical wiring, consult a qualified electrician or HVAC technician. They can properly wire the low water cutoff and ensure that it is working safely and effectively. In addition to the low water cutoff, consider installing other safety devices, such as a high temperature limit switch and a pressure relief valve. These devices can help protect the boiler from damage and prevent hazardous conditions. Perform regular maintenance on the boiler to ensure that it is operating safely and efficiently. This includes inspecting the wiring, cleaning the burner, and checking the water level. Keep a log of all maintenance and repairs performed on the boiler. This will help you track the boiler's performance and identify any potential problems. Wiring diagrams are an essential tool for understanding and troubleshooting electrical circuits. A wiring diagram shows the connections between different components in a circuit, using symbols and lines to represent the components and wires. Wiring diagrams can be used to install new equipment, troubleshoot problems, and make repairs to existing circuits. There are several different types of wiring diagrams, including single-line diagrams, ladder diagrams, and point-to-point diagrams. A single-line diagram is a simplified representation of a circuit that shows the main components and their connection. A ladder diagram is a type of wiring diagram that is commonly used for control circuits. It shows the components arranged in a ladder-like structure, with the power source at the top and the load at the bottom. A point-to-point diagram shows the exact location of each wire and component in a circuit. When working with wiring diagrams, it is important to understand the symbols and conventions that are used. Common symbols include circles for components, lines for wires, and triangles for grounds. It is also important to pay attention to the colors of the wires, as these can indicate the voltage and function of the wire. When troubleshooting a circuit, start by examining the wiring diagram to understand how the circuit is supposed to work. Then, use a multimeter or other test equipment to check the voltage and continuity of the different components in the circuit. If you find a problem, use the wiring diagram to trace the circuit back to the source of the problem.